And if you have missed the first one, demonstrating that Zephyr could be, in some cases, a good alternative to Linux, do not hesitate to visit our website through nxp.com in the section training. So today, we will present you how to rapidly build and scale a modern IoT ecosystem with NXP's Freedom iNix93, which act as a Linux gateway, and the Freedom RW612, which act as Zephyr node. This webinar will showcase the straightforward configuration of a Linux-based MQTT broker with Node-RED, alongside real-time sensor data collections from Zephyr power nodes. So I'm Thomas Aubin, and I'm managing the regional marketing group in Europe. And before giving the floor to Roy, I will first introduce you a couple of insights relative to NXP and our newest low-cost hardware enablement called Freedom Board. First, I want to remind and give you a super quick overview of NXP. If you want to know more, do not hesitate again to visit our website at nxp.com. So, NXP company is based in Eindhoven in Netherlands and employ more than 34,000 people across the world. We have a strong R&D presence in more than 30 countries, and we do serve roughly more than 25,000 customers, dealing in a wide variety of applications, and we have a record revenue of more than $30 billion that we have done back in 2023. Our main markets are automotive, industrial, and IoT, mobile and communication infrastructure. To serve this market, NXP design and develop different types of solutions going through MPU, MCU, analog, such as power management IC, battery management solutions, transceivers, sensors, wireless devices like Bluetooth, Wi-Fi, and RF security, and so on. One of NXP's main strengths is the breadth of our embedded portfolio, covering a wide range of different products. As I said, analog, like power management sensor, analog front-end, to some connectivity like wired and wireless solutions, and a strong processing offering with our MCU and MPU portfolio. To enable optimized solution, our goal is to offer to customers a comprehensive system approach, an ecosystem, to maximize the value proposition that we can bring to our customers. For this, and to offer generic and scalable approach, NXP deployed different layers of components. Based on hardware and software foundations, NXP offers and delivers technology pillars around security, connectivity, HMI, vision, machine learning, safety, and many more. To demonstrate all of this and accelerate application development, system-level approach are addressed through reference design, proof of concept, or software package that can be executed on our evaluation kit or our newest Freedom ecosystem. This Freedom Board ecosystem approach has started to be deployed, and the goal of this is to deliver an optimized, simplified approach for developers. It's all about application development experience, and it is to make the NXP technologies affordable, scalable, accessible, and quickly deployed by you. This slide gives you an overview of our different Freedom Board solutions, starting from teeny MCU up to our recent MPU Freedom Board versions. On such a board, you have all necessary interfaces and engine to start your application development and test NXP solutions. It is a highly flexible hardware with capabilities to use expansion boards to address specific needs required by your project. The Freedom Board comes with a complete software ecosystem and tools like MCU Expresso SDK, IDEs, add-ons configuration tools, and more. Freedom Boards come as well with an open source software like Debian, with a friendly graphic user interface, a simple package management for fast recompilation and open source licensing, or, for example, Zephyr, which is a real-time OS with strong middleware collection and hardware abstraction layers to enable rapid code porting and reuse. NXP has developed different set of examples that you can use to test and evaluate or reuse for your development. You can leverage from common industry headers to stack add-on functions, and you can benefit from a robust community to support you during the project development phase. So here is an example of expansion board illustrating the technology pillars I talked about during previous slides. If you want to know more or check our latest offer, don't hesitate to go and click on the link provided in this slide. In conclusion of this short Freedom presentation, we can summarize here some benefits you will get with Freedom hardware and its ecosystem. First, it's an affordable hardware that will drastically reduce the money investment to evaluate NXP technologies. Second, it's an intuitive way to find some source code for demo through the Application Code Hub portal, and where you can as well get access to some application notes and software example. Then, it's a comprehensive choice of expansion boards that, combined with Freedom Board, will give you the possibility to quickly create cool solutions demo. If you want to know more about Application Code Hub, scan this code bar and explore applications example already available. On the left of this slide, you can see the look and feel of the portal, where you will be able to find multiple ways to filter and choose the right resources to start with. Freedom is as well leveraging community of users to help newcomers to navigate in Freedom ecosystem. Through the community, you can access to knowledge-based articles and trainings that will help you to ramp up on it. Do not hesitate to navigate through this link. I'm sharing with you this link as well if you want to get more detailed information about our Freedom catalog and have a look and come back to us if you have any questions. Okay, so now I would like to present you briefly what Roy from IC6 will use today to show the multi-OS IoT system using a Linux gateway with Zephyr nodes on Freedom. One of the Freedom is based on our recent i.MX93, which is our first i.MX processor to integrate the ARM Cortex-A55 core. This core brings more energy-efficient performance to Linux-based edge applications. It is also the first i.MX to integrate the ARM Ethos U65 micro neural processing unit, which enables developers to create more cost-effective and energy-efficient machine learning applications. It integrates our own edge-lock secure enclave hardware to deliver advanced security directly on the chip. It's a very flexible and scalable product built with our Energy Flex architecture to optimize performance and power efficiency. It's offered in commercial, industrial, extended industrial, and automotive level qualification, and backed by NXP's 15 years product longevity program. So the Freedom i.MX93 is equipped with the i.MX93 dual Cortex A55 version, which runs at 1.7 GHz and LPDDR4 non-volatile memory type. A u-blox Wi-Fi 6 M.2 module based on NXP IW612 system on chip is mounted by default and enabled by an open source SDK. The board comes with a set of peripherals to address a wide range of use cases, and it's sold for $80 as suggested resale price and available since this month through nxp.com or your favorite distributors. About the second Freedom used in this webinar is based on our recent 3-radio wireless MCU supporting Wi-Fi 6, BLE, Thread and ZigBee called RW612. This product is based on Cortex M33 core running at 260 MHz and managed communication stack and application. Matter is enabled, and this SOC is a highly integrated solution ideal for applications requiring optimized performance cost and power consumption. The solution is offered in commercial, industrial level qualifications, and is backed as well by NXP 15 years product longevity program. So the Freedom RW612 is equipped by RW612 system on chip, some quad SPI flash, PS RAM, a temperature sensor, a PCX antenna, and a set of peripherals. It's available for $30 suggested resale through nxp.com and is available as well in your favorite distributors. So now that I have made the hardware presentation, let me give the floor to Roy, who will present you how you can enable multi-OS IoT system by using a Linux gateway and Zephyr nodes on NXP Freedom boards.
Thank you, Thomas, for the introduction. And hello, everyone. Welcome to today's webinar. In this session, we'll discuss the topic multi-OS IoT system, Linux gateway with Zephyr nodes on NXP's Freedom development boards. So our goal is to walk you through the process of building IoT systems using a combination of Linux gateways and Zephyr-based nodes. We'll also highlight how NXP's Freedom development boards can support your project efficiently. So the focus will be on simplicity and ease of use, making it clear how Zephyr can help streamline IoT application development, whether you are new to IoT or already familiar with it. So let's get started. So just a quick word about AC6, the company I work with. We've been in embedded system training for over 20 years, providing training and support across a range of domains like RTOS, including FreeRTOS, ThreadX, and so on, Linux security, FPGAs, and more. So we have a large catalog with over 150 courses, and we've also been working with NXP, providing specialized training on their SoC implementations, like the IMX series and CoreIQ. And we are also Zephyr training partners. We have developed a course that covers basics to advanced topics, like configuring Zephyr, device driver model, and common subsystems. So for those who aren't familiar with my work, I am Roy Jamil. I hold a PhD from ENSMA on embedded systems, and I had the privilege to becoming a representative on the Zephyr Technical Steering Committee, the TSC. Over the years, I've developed a comprehensive Zephyr training course that goes beyond the basics to include more advanced topics. I also provide consulting and support on Zephyr and Linux. So here's a quick overview of what we'll be covering today. We'll start with an overview of Zephyr, giving you a brief introduction to its main features and why it's a good choice for IoT application development. Next, we'll talk about IoT applications on NXP platforms. From there, we'll dive into a specific example of an IoT application built using Zephyr, highlighting the main steps. After that, we'll discuss the configuration of a Linux-based gateway, which ties everything together and acts as a central hub for communication between devices. Finally, we'll wrap up with a conclusion, summarizing the key points and addressing any questions you might have. So let's get started with the first topic, the Zephyr overview. So let's start with a little background. So Zephyr originated from Virtuoso RTOS, which is developed by Wind River. It was later renamed Rocket when it became open source. And in 2016, it joined the Linux Foundation as hosted collaborative project under the name we know today, Zephyr. So what exactly is Zephyr? So it is a small operating system that's ideal for embedded devices. It is vendor neutral, meaning it's not tied to any specific hardware or company, which gives developers a lot of flexibility. So what sets it apart is its modularity and configurability, but more importantly, it's built with security in mind. So let's talk about the contributors to Zephyr. So Zephyr has seen significant growth and engagement from a wide range of contributors. It's backed by a strong and active community with recently reaching over 100,000 comments. So the contributors are from diverse backgrounds, ranging from individual developers to large companies. So this helps in creating a robust, well-maintained system. So Zephyr is not just a project, it's a collaborative effort across industries and sectors. So as you can see in this graph that shows the average number of unique contributors, which is constantly increasing, and it is higher than all other RTOSs combined. So which shows the level of engagement and ensures that Zephyr is constantly evolving to meet the needs of developers worldwide. So when we talk about Zephyr, it's important to recognize that traditional RTOS features are just a small part of what this operating system offers. So Zephyr goes far beyond the basic capabilities that we see in conventional real-time operating system. Here we're offering a wide range of advanced features that makes it highly adaptable and powerful for modern embedded systems. So let's break down the architecture. So as illustrated, you can see here that we have the hardware abstraction and portable drivers. So Zephyr is designed to abstract the underlying hardware, making it possible to develop applications that can be ported across different architectures, no matter what hardware platform you are using, whether you are working with ARM, x86, RISC-V, and so on. Next, we see connectivity protocols and features which support a wide array of communication protocols like Bluetooth, Wi-Fi, Ethernet, among others. So this is especially important in IoT and other embedded applications where devices need to communicate with each other reliably and securely. So while Zephyr includes all the features you'd expect from an RTOS, it's the added layer of connectivity, configurability, and hardware abstraction that truly makes it a modern and versatile solution for embedded that allows to write a portable application that can work on any embedded platform. So Zephyr supports different system configuration. We have the single core configuration, which is the most straightforward setup, where Zephyr runs on a single uniprocessor SoC, managing applications on a single core. In this configuration, Zephyr handles the entire system, providing a lightweight and efficient operating environment with minimal resource overhead. So next we have the AMP, asymmetric multiprocessing, which involves cores with different architectures. We have SMP, so which is we have multiple cores with the same architecture, and finally we have also a hypervisor configuration, and there are also other configurations that can be enabled thanks to Bluetooth and other features. So the build system in Zephyr is another area where it's truly shined in terms of ease of use and functionality. So we have a tool called West. So this is a command line tool that serves like a Swiss Army knife that you can use it for building, flashing, debugging, and a lot of things. So Zephyr is based on CMake, so to handle the build process, and it's going to generate the build script that's going to be used later in order to do and perform the actual build. And the configuration system uses kconfig and device tree that can help us to easily enable, disable features and to customize devices and settings. So let's now talk about one of the most important features which is the standard APIs provided by Zephyr and how they simplify development. So Zephyr offers uniform APIs for device drivers and system features. So these APIs abstract the hardware, making it easier for developers to work with different hardware platforms without worrying about low-level complexities. So using the standard APIs comes with several benefits. So first, it's consistency. So developers get uniform interface across various hardware platforms, which simplify development. Second is portability. With Zephyr, you can write your code once and deploy it on multiple devices with minimal changes. So this modular and standardized approach encourages community contribution, allowing developers to share samples, demos, and enhance with ease. So these APIs also enable faster and easier development. They include pre-built, tested APIs that you can use to quickly assemble your application. So they make it straightforward to integrate networking, communication protocol, as well as unify sensor integration through standard interfaces. So Zephyr provides hundreds of samples that act as example application to showcase its features. So these samples are directly available within the Zephyr project repository and offer a solid foundation for developers. So I think this aspect is often underestimated, but it is really very important. So these samples serve as a tested baseline, making rapid prototyping much easier and reducing the time needed to get started. So the samples cover like wide range of functionalities. It could be basic operations, or it can go through advanced networking and connectivity implementations. So additionally, you can have resources like Freedom Training Hub that can also help you to support developers and utilizing these samples effectively and providing additional practical examples and tutorials to accelerate development. So regarding the development environment, NXP added support to Zephyr in their extension MCU Espresso for VS Code. So this extension significantly simplifies the process of developing, building, debugging Zephyr applications. It automatically installs all the necessary Zephyr host tools and prerequisites, ensuring that you can get up and running. You can get up and running quickly without having to manually configure your development environment, and it works on Windows, Linux, macOS. So additionally, it supports comprehensive Zephyr project management, so allowing you to easily import existing Zephyr project and to create a new one, and then easily updating your code. And you can access advanced debugging tool directly within the IDE. So in addition to, it integrates seamlessly with Zephyr configuration tool like device tree and kconfig. And for getting started, we have a tutorial on AC6 YouTube channel that you can just watch to get started using this tool easily. So for IoT application, so let's go over now the setup for this example. So here on the left, we have the Freedom RW612 board running on Zephyr application. So it is going to run a Zephyr application, and this application is responsible for acquiring data from sensors, such as the temperature, the accelerometer data, and also uses MQTT to publish this sensor data. So on the right, you have the Freedom IMX93 board, which acts as a gateway. It runs Linux, Yocto-based configuration. So it was generated with Yocto provided by NXP, and includes the MQTT broker to receive data from the RTOS. Additionally, it uses the Node-RED in order to process this data and to visualize them. So the communication between these two boards is done using MQTT, which is a lightweight messaging protocol designed for IoT applications. We are going to show how this setup can be implemented simply and efficiently using Zephyr and Yocto. Both platforms will provide the tool and feature needed to streamline the process, making it really very easy and straightforward to connect and manage devices on this multi-platform IoT system. So this is the actual physical setup. So on the left, you have the Freedom IMX93 gateway running Yocto Linux with MQTT and the Node-RED. And in the middle of there is the Freedom RW612 board running Zephyr application that is connected to a sensor where the sensor is on the breadboard. So the board communicates via MQTT with the RW612 publishing sensor data to the gateway. So let's present really quickly the Freedom IMX93. So it features the application processor with dual-core ARM Cortex-A55 and a Cortex-M33 with a neural processing unit for AI task. So the board also supports Wi-Fi 6, Bluetooth 5.3, along with display output via HDMI, and it is compatible with Debian and other operating systems. Now let's look at the Freedom RW612 board. So it features an ARM Cortex-M33, and the board offers extensive wireless connectivity options like the Wi-Fi 6, Bluetooth, BLE, and so on. So MQTT. MQTT is a lightweight messaging protocol. So it is designed for devices with limited resources and unstable networks. It works across various communication methods like Wi-Fi, Ethernet, and Bluetooth, and other. So it uses a publish-subscribe model. So a publisher is going to send a message. So it's going to send messages on specific topics to a broker, and the broker is going to receive these messages and is going to route them to the appropriate subscribers based on their interests. So the workflow is simple. A publisher is going to send message to the broker, and then which is going to check the list of subscribers to the topic and going to forward the message to those subscribers. So the benefits of MQTT includes reduced network overhead, scalability with more devices, and the decoupling of message sender and receivers, allowing for flexible communication between the different devices. So traditional RTOSs, they face a lot of challenges in IoT setups. So first, the fragmented ecosystem often lacks a unified API for device drivers and system features, making integration a bit complex. So configuration can also be challenging with high effort required for initial setup, driver integration, and limited flexibility to adapt diverse applications. Also, in addition to the security vulnerabilities are another concern. So with minimal focus on the integrated security features and challenges in ensuring like a secure communication protocols. The lack of modularity and monolithic structure that impacts the scalability and the adaptability, making it difficult to reuse components across projects. Additionally, there's limited community support that can slow bug fixes and feature updates. So while reducing access to ready-made demos, libraries, and resources. So these challenges highlight the importance of a modern solution like Zephyr that's going to address these pain points effectively. Now let us look at the Zephyr side IoT application. So this is the application. The Freedom RW612 application, which is built on Zephyr, integrates a sensor. So the accelerometer sensor, which is the MPU 6050. So that offers 6-axis sensing through 3-axis accelerometer and the 3-axis gyroscope. It also measures the chip temperature and communicates via I2C interface. So this is useful for connectivity. So the board supports Wi-Fi and Ethernet. And we are using MQTT protocol for publish-subscribe messaging here that allow the board to send sensor data to the gateway. So Zephyr includes already a driver out of the box for the MPU 6050, eliminating the need for a custom driver development. So we can easily configure this MPU 6050 through the Zephyr device tree and some kconfig configuration file. And in addition, Zephyr provides a sample for easily getting started with this one. So the sample can be found under sample sensor MPU 6050. So you have already the code, so you can easily get started. So the description of the sample, so it is a sample application that's going to periodically measure the sensor temperature, accelerator, velocity, displaying the value on the console with the timestamp since startup. So it is very basic sample, but it will provide everything you need in order to get started quickly. So to customize the application, so we have firstly we have two type of configuration. You must enable the drivers using the kconfig features. So you enable I2C and the sensor driver. So we can just easily add config I2C equal yes and config sensor equal yes in the project.conf. And then you should tell in the device tree overlay. So you should define the sensor and just tell it is which I2C device is going to handle it. So here we're using the FlexCom2, which is an I2C device, and inside it, this is when we're going to define the MPU 6050 device that is going to be managed through this setup. So to retrieve the sensor data from this MPU 6050, firstly we need to access the sensor device pointer. So this is like part of the Zephyr device model. So to do this, you use the function device dt get1. Macro, and this macro is going to link the sensor node to the device tree. Then, to get the sensor value, you define a variable of type sensor value. So it is a structure sensor value that can help us to get the temperature, the accelerometer, and the gyroscope data. And then you use the sensor channel data function to retrieve the values. And they specify the desired channel, like the accelerometer, the gyroscope, or the temperature. And then we're going to put them in some variables. So as you can see here, just using few simple functions, I was able to retrieve the data from the sensor that I want. So what I'd like to mention here that the code is really portable. So here there's nothing specific to any specific board. So which means that if we need to migrate to another platform or upgrade the hardware, we only need to adapt the device here without the need to modify the source code. So Zephyr provides a ready-made sample for integrating the MQT publisher. So as you have noticed, like everything, we already have samples to get started easily. So this sample is going to help us to showcase how to connect the MQT broker and to publish messages. So we can establish and maintain the connection easily with the broker, and we can just send the payloads using the specified topics. So it uses of course, the typical Zephyr configuration system like the kconfig and overlay files, like any other mechanism in Zephyr. And it serves as a practical starting point and accelerate development by offering a pre-tested implementation. So here you save time and effort because it was already available, so you just use it and you get started with it. So Zephyr also have full support for IP networking, so TCP/IP and sockets. So which means that configuring this feature is straightforward through like the typical Zephyr configuration system. So in here in the kconfig configuration, I just enable networking to and then enable the networking, the standard socket, and activated the TCP protocol stack and over the IPv4. And to integrate the MQTT library, the only thing I needed is just to enable the config MQTT library equal yes. So no manual adjustment to the project is required. I don't need to add any special libraries. I don't need to add anything here. Everything just already provided. So just the fact that enabling the single configuration option will seamlessly add the MQTT support, which really simplifies the integration process. And to implement an MQTT publisher, first we need to configure the broker information. So you set up the SOC address, the input structure for the broker by specifying the IP family, the port number, and the address. And next you must initialize the MQTT client using the MQTT client init function. And then you configure the client by assigning the broker information, the callback, the ID, and other optional parameters like the username and the password. And there you go. So the MQTT publish functionality uses the JSON formatted message payload. So you need to reformat your message that you wanted like in a JSON format, as seen in this example, where we set the temperature, the accelerometer data, and the gyroscope like in this JSON special format. And Zephyr actually support this. You just need also to enable a config option. So config JSON library equal yes, and there you go. You have JSON enabled. And then you just need to publish the message. So you set the needed parameters like the quality of service, the QoS, the topic information, the name, the size, and some other flags. And then you just assign the JSON payload data, its size, and you send it. So finally, you just use the MQTT publish, and you're just going to send the message to the broker. That's it. This is everything that we need from the Zephyr side. So we might consider securing the communication. So to enable the secure communication, we such as establishing a secure MQTT connections. So this involves using a CA certificate and pre-shaped keys. So this is needed to ensure trust. So you must register them, and then the Zephyr networking feature is going to handle everything. And by default, in addition to this, Zephyr also supports is going to isolate the networking feature from the main and kernel code. And this is using the Zephyr's user mode system. This isolation is going to ensure that network operation, including MQTT connection and also other data transmission, are going to be protected from malicious interfaces. So from malicious interference, I mean. And if any attack happen here, is going to the impact is going to be limited because there will be no impact on the kernel size and high privilege operations. So this provides a robust and secure environment for the application. So on the other side, so on the Linux setup, so the Freedom here, the Freedom IMX93 setup uses the IMX Freedom NXP Yocto distribution to create the image. So this Yocto, if you're not familiar with Yocto, so Yocto is a tool that's going to help us to create a customized and tailored Linux distribution. And here we just need to add the needed layer, the packages and layers into my Yocto setup. So for MQT and networking support, the setup uses a layer called Meta IoT Cloud layer that's going to create a custom, and then you need to create the custom image that includes some packages like Mosquito, the Mosquito clients, which is basically the MQTT broker and clients. Node-RED, which is a flow-based development tool, so this is mainly for processing the data and visualization. Node.js and NPM, which is a package manager for managing dependencies. This combination of Yocto layers provide all the needed features in order to create this image. So all I need now is to build this Yocto image and deploy it onto the hardware. So you also need to configure the Wi-Fi. So on the IMX93, I just need to establish the Wi-Fi connection by enabling the network connectivity. So to do this, I should load the Wi-Fi module by using the modprobe command. And I should also specify the WA supplicant conf in order to specify the name of the SSID, the password, and other information in order to establish the network connection with the Wi-Fi. And also, it would be a good idea to set a static IP so I can easily retrieve the different the broker. So regarding Mosquito MQTT, so Mosquito MQTT, so this must be configured using etc mosquito.conf. So here we specify which port we're going to listen, and the protocol is going to be MQTT. And here we just need to restart the Mosquito service in order to take into account any changes that we have previously made. So if you have noticed that we have the different MQTT publishers that are going to send the messages to the broker, and then the broker is going to distribute it to different subscribers. You might also consider adding some other additional security measures here by, for example, disabling the anonymous access and also other security features. So if you can notice here in this MQTT example, on the MQTT publisher side, we have this Freedom RW612 that is running Zephyr. It's going to collect the sensor data, it's going to format them, and then it's going to publish it to the specified MQTT topic. And then the broker that runs Mosquito, so Mosquito, this is the open source platform that's going to help us to create this broker, is going to that runs on the Linux on the Freedom IMX93, is going to be like the central hub. It's going to receive messages from Zephyr and then it's going to send it to the subscriber, which is in this case is Node-RED. So Node-RED that is running on the same IMX93 board is going to subscribe to a topic, receive the sensor data, and is going to provide a web-based dashboard to monitor and visualize the data. So this setup demonstrates the simple and the efficient integration of this IoT system. So what is Node-RED? So Node-RED is a visual programming tool that allows you to wire together devices, APIs, and services through a browser-based interface. So it is an open source, making it widely accessible. So it uses a flow-based development model, enabling users to create data flows by connecting nodes, which simplifies integration tasks. And it is built on Node.js for application development and data handling. Node-RED is particularly useful for IoT and automation projects, allowing for quick prototyping and deployment of real-time dashboards and automation systems. Basically, you're just going to provide the dashboard so we can just easily use it. So it's also extensible and community-driven, so it supports many add-ons and benefits from a large community that shares a lot of resources and solutions. So this is a great tool that is easy to use, that is very powerful. So regarding the dashboard, which is an add-on for the web-based user interface. So it provides a graphical interface for real-time data visualization and control. So the user can just add customizable widgets like charts, button, gauges, and many other things like charts and everything that you can use in order to display the data. So this is ideal for IoT and automation, and it's user-friendly interface. So it has a user-friendly interface that allows for drag and drop configuration, make it easy to customize layout, adapt the dashboard, and just simplify everything by just doing the quick simplification. So regarding the configuration of Node-RED, it is pretty straightforward. So you just need to enable the using the web-based UI for live data visualization. You need to make sure that the Node-RED is installed. So to install the Node-RED dashboard, you just do npm install Node-RED dashboard, and there you go. You have now the dashboard installed. You need to restart the service, and you have now the dashboard installed. So the dashboard, you expect it to visualize information like the temperature, some charts, the humidity. So anything that you're collecting from the sensor, you need to visualize it now thanks to the Node-RED. By the way, note that not only the dashboard, we can also use it for other processing if needed. So to configure it, we're just going to show you some steps to highlight how straightforward it is to configure it. So basically, there is the Node-RED flow, which is a which is an editor on the web navigator. You just open the IP address and the whatever the port that you have used to configure it, and here you just drag and drop the components and widgets in order to just simply configure it. So let's go through these simple configuration steps that we have followed in order to set up this dashboard. So firstly, on the Node-RED, I just need to for setting it up, first I need to connect to the MQTT broker. So I'm going to use the MQTT in Node to connect to the broker, and then I need to subscribe to the topic, which is here sensors, and I'm going to receive messages in the JSON format. So I should specify that they should be received in the JSON format. So, and then I must extract the data. So I must create a custom function that's going to process this JSON payload and extract the specific data field like temperature, accelerometer, and gyroscope. And each function is going to take the messages, the message object as input and output the processed data visualization. So here you can see here the extract accelerometer function is just a function that's going to read the accelerometer data and just return it. And then to display the data, so finally for displaying the data, I need to connect the processed data to the dashboard, to the widgets like the gauge and the charts. And I need to configure widgets by selecting the type and setting the unit, limits, and the other display information. So the dashboard we set up here, it looks like this. We can see the accelerometer information, the gyroscope, and the chip temperature. So here the temperature that we're getting is not like the ambient temperature, it's like the temperature inside inside the chip, inside the sensor. So here's just so this is a demo to show you how the output would look like. So you can see here we're just moving the sensor and we have live feedback on all the outputs. So the gyroscope, how it's moving, the accelerometer data, everything. We can just get all the information live directly from the board into the dashboard here. So this is, as you can see, it's a nice way to displaying the information. Yeah. So in conclusion, so to wrap up, let's summarize the key takeaways here. So this is the integrated ecosystem. So we have Zephyr and Linux provide a seamless multi-OS environment that supports a robust communication and efficient data handling for the IoT system. We have a developer-friendly tool. They use for pre-built APIs, sample application, and tools like the MCU Espresso, the Node-RED. It simplifies the development process and shorten the time to market. So we have a lot of samples, we have a lot of resources that we can just directly use. Also the security here, so Zephyr's built-in security features and real-time performance capability make it like an excellent choice for security IoT. So it's not only easy to use and powerful, but also it has all the security features that you need. That, by the way, very hard to configure on using other real-time operating system. And in many cases, we actually is going to skip the security on the microcontroller side because it is very hard to set it up. So we also have a strong community here. The active and collaborative community surrounding Zephyr here ensures the access to the shared resources, update, assistant. You don't need to worry about everything here. You have the community can always provide a lot of feedback that can help you to advance really quickly. So other features that can also be added here. So as you can see, we have only showed the dashboard. We did like a simple processing, but here just to showcase how easy it is to set it up. But you can do some very complex and advanced processing if needed. Other things that you might also consider is like minimal changes and that provide a lot of flexibility. So here you can, because in Zephyr you can enable advanced feature with minimal modification to the core application. So here the built-in samples can show you how to quickly integrate this enhancement. You can enable the power management subsystem. So there are just a couple of configuration options. You just enable them, and there you go. You have power management enabled. You don't need to do a lot of things here. Secure boot. So of course it would be a good step to enable secure boot just to protect the system from unauthorized modification. And you might also consider over-the-air updates to deploy remote firmware updates. And for this one, Zephyr offers a lot of solutions, a lot of techniques in order to provide OTA updates. In addition, on Yocto, there are also many platforms and many solutions that can also help you to provide the OTA updates. So what's next? Start building your IoT solution. You can use the NXP Freedom boards and of course Zephyr. So and if you want to get more information and learn more about the NXP about the NXP features, about embedded Linux, about Yocto, and also regarding the Zephyr training, yes, feel free to reach out to us. So the AC6 will provide professional training on all of the topics covered here. In addition to IoT courses on MQTT and other features. Well, thank you all for your time and attention throughout this presentation, and I hope you found the discussion on Zephyr and IoT application useful for your project. Now, if you have any questions, just feel free to ask. Thank you.